Unit 6, Section 3. Here we have our last 3 examples. So, this first example, given 2 similar triangles and the perimeter of one of them. So this is giving us a little different information than we're usually used to giving. So I'm going to draw a picture so we're a little more clear. So we have a triangle, ABC, and then another similar triangle. I'm going to draw this one a little bigger. Oops, MNP. And note how I drew the letters, they matched up, how they should with their similarity statement. And all it tells me is the perimeter of ABC is 150. Okay, so what's the perimeter of MNP if MNP is 3 times larger? So right away I can interpret that 3 times larger as my scale factor is 3. Because I know I'm making it bigger, I'm blowing it up, so it has to be greater than 1, and I take it times 3. Or I could also just think about it as new over old. The new one's 3, while the old one's just 1. And so, here I should label this a little better. This is new, this is old. And so, let's see, I know the perimeter of the old, so that's in the bottom. So I know the perimeter is 150, and then I'm solving for the perimeter of the other. And this one, you might not have even had to set that up, but it's good to just in case. So you're thinking about, well, 3 times 150 is going to give me my x, which is what I want, and that's going to end up being 450 units. So you could have just thought about that, well, I know 1, and I know it needs to be 3 times bigger, so I just multiply 150 times 3. Or you could set up the proportion to see how you cross multiply and eventually get your desired perimeter. Okay, so then MNP has an area of 48. So I'm going to write 48 here in the middle. What's the area of the other one? Well, for this one, I'm going to set up the proportion again, just to be safe. So I have, let's see, new over old. So I'm going to do the area of my new, which is MNP, over the area of my old, which is ABC. And I know that since I have area, it should be k squared, so it'll be 9 over 1. So 3 squared will be 9. So I can set that up. 9 over 1 equals, let's see, I know the area of MNP is 48, so I'll put that on top. And then I'm solving for the area of the other. So I'm going to cross multiply here. So 48 equals 9x. Therefore, x is 48 divided by 9, which is 5.3 units. And since I'm doing area, units squared, or square units. All right, here we have a new example. The volume of a cylindrical can is 210 units cubed. What's the volume of a similar can that is half as tall? So I'm going to set up my proportion to be my new over old. Or I can think about it, my new one, it's going to be smaller. It's half as tall. So I'm going to do small over big. That just to keep things straight. And I know, all I know is k cubed, so how things relate to each other. And so, since it's half, I know it has to be 1 over 2 has to be my k, but I know I have to cube it. So k cubed is 1 over 8. So I was thinking about small over big. Small was 1, and then the big one is twice as big. So it's all about kind of getting it straight in your head. Am I shrinking it? Am I blowing it up? How does that work? So k cubed is 1 over 8, and then from there it's fairly simple, and that you do 1 over 8 equals, let's see, what do I know and what am I looking for? I know that the volume, the volume is 210, oh, excuse me, and it asks for the volume of a smaller can. So I know the big one, so I know 210, and this is the one I solved for. So I cross multiply. So 8x equals 210. Divide both sides by 8. So x equals 26.25 units. And since it's volume, it'd be units cubed. All right, so the key for that one was realizing what is 1/2. And realizing 1/2, that was our k. And so we had to figure out k cubed. And so that's how we got that 1/8. Last example, figure 1 has a volume of 5 units and the surface area of 4 units squared. Figure 2 has a volume of 40 units. Okay, and then it's saying they're similar, so it wants the surface area of the second one. So to be consistent, let's see, I guess I can't make that much bigger. I'm going to do figure 1 over figure 2. Because it didn't really tell me which one was new or old or anything. So I'm just going to write that just to be consistent. Okay, so it told me that there's the volume of 5 and a volume of 40. And then it said there was surface area of 4, and then it wants me to find the surface area of the other. So I'm going to need to find first by comparing the volumes. So I'm going to think about, let's see, I'm going to think about, because I want to eventually get to my k. So I can figure out what k cubed is, because I can think about the volume of 1 over the volume of 2. So the volume of 1 is 5, the volume of 2 is 40. I can simplify that down. 5 goes into 40 8 times, so 1/8. And that is k cubed. And so from that, I can do the cube root. So if I do cube root of k cubed equals cube root of 1/8, I can get k equals, well, cube root of 1 is just 1. And then you can plug this in your calculator, or you can just think, what cubed equals 8? And I think 2 times 2 is 4 times 2 is 8. So I know that k is just 1/2. All right, so I know k cubed, I know just k, but I want to figure out surface area, so I need to do k squared. And so 1/2 squared is 1/4. So you really have to keep straight in your mind, what am I talking about, and what do I need to do with my scale factor? And so back to the original question, what is the surface area of figure 2? Well, I'm going to set it up with 1/4 because I'm doing surface area, so I use k squared. And I know the surface area of figure 1 is 4. And I want to figure out the surface area for figure 2. So cross multiply, and we actually just get that x equals 16. And that would be, since it's surface area, that would be units squared. So 16 square units. So that last one really tested you in thinking about what k's am I using, how can I find just plain k, the scale factor, and then how can I use that to find the scale factor for areas. So that concludes section 3. Good luck on your homework.